This one, and it's really simple. So, what are one-sided limits? One-sided limits are used when evaluating a function that approaches two different values when the input approaches a specific point. So, you might say, then why don't we use two-sided limits, or why don't we just use the limit term in general? And we'll take a function like f of x equals 1 over x, which is also the function of Gabriel's horn. An extremely interesting function, and I really like it to explain this topic. So we have 1 over x. And as we zoom out here, we see that as x approaches 0 from either side, they're approaching two different values. So therefore, we must evaluate each limit separately. And we do so with a notation that I'll explain later in this video. But we see here that as x approaches 0 from the right-hand side, as x approaches 0 from the right-hand side, we approach infinity. As x approaches 0 from the left-hand side, we so we see here that they approach two different values when x reaches a specific point. In this case, it would be 0. As x approaches 0, which is that specific point, these functions go to different values. And then we can write this is the limit as x approaches 0 f of x equals what? So if they're two different values, do we write infinity plus negative infinity? Or infinity comma negative infinity? And I explained this in the previous video, but you don't. And what you do is you approach or you evaluate this differently. And what happens is that you'll get functions that look like this, or limits that look like this. And these are called one-sided limits, as explained before. And simply all this means is, or what the plus and minus signs mean, as x approaches 0 from either the right-hand side or the left-hand side. And the right-hand side is the positive side. So as x is approaching 0 from the right-hand side, with the plus side, we come back to this here. As x approaches 0 from the right-hand side, we get infinity. So this is the limit here, and as x approaches 0 from the left-hand side, we get negative infinity. Now let's take a different function to understand this idea, and we'll take f of x equals x squared, x minus 2, and here we'll write this into the calculator, x minus 2, and we see here that they approach two different values again, so therefore we must use the one-sided limit, because since they don't approach the same value as x approaches positive 2, there is no limit, and we're going to have to evaluate one-sided limits. So as x approaches 2 from the positive side, the right side, and x approaches 2 from the left side. And what we'll get here is, what you can actually do here is, hold on, I'll explain this after. We evaluate this as x approaches 2 from the right-hand side, it goes to infinity again, and this side goes to negative infinity again. But here's the interesting thing. You can evaluate limits by getting infinitesimally close to this value here without actually touching it. Because if you touch it, it's going to give you an undefined value. So if you get infinitesimally close to it from the right-hand side, and the right-hand side, we can just use a very close point from the right-hand side or from the right side. We get this. And you might calculate this in your calculator, and the value is going to be 40,000. And you're going to assume, okay, so is the limit 40,000? No, because it's always safer to get even smaller and smaller to that point to see what the function is actually reaching. Or you can just look at the graph like I did and figure it out. So in review, simply a one-sided limit is when the left-hand side and the right-hand side at a specific point go to different values, and therefore there is no one standard limit, and you have to calculate each limit separately.